Hello students, this is Indrani ma'am from SIP Rasayan. In this lecture, I am going to explain some increasing order type questions from aldehydes and ketones chapter. Question 1. Arrange the following compounds in increasing order of boiling points. Acetaldehyde, ethanol, propane. Now see, this is acetaldehyde molecule. Here oxygen is more electronegative, so it is having delta minus charge, and carbon is more electropositive, so it is having delta plus charge. Delta plus, delta minus, delta plus, delta minus. So molecule is having dipole. So here dipole-dipole interaction is present. In ethanol, between two molecules, intermolecular hydrogen bonding is present. And in propane molecule, there is very weak van der Waals force. Remember, intermolecular hydrogen bonding is much more stronger than dipole-dipole interaction, which is much more stronger than van der Waals force. And therefore, increasing order of boiling points is this one. Next question, increasing order of nucleophilic addition reaction is, some compounds are given, methanol, propanol, butanone, ethanol, propanone. First, draw the structures. Methanol means this one. Propanol means CH3, CH2, CHO, aldehyde. Butanone is this one. Ethanol, aldehyde. Propanone, acetone. Okay, propanone is nothing but acetone. These are the structures. In nucleophilic addition, at the first step, pi bond will break and nucleophile attacks here. We will get this tetrahedral species, and here at the first step, H plus will attack and will form this compound. Now see, this carbon is sp2 hybridized, and here this carbon is sp3. So here bond angle is approximately 120 degree, and here bond angle is decreasing. It is 109 degree 20 minute approximately. So you can say, with increasing crowding on carbonyl carbon, crowding also increases here, and the reaction takes place via tetrahedral transition state. So at the transition state also crowding will increase. So reaction will become slower. This is steric reason. So you can note down, with increasing crowding on carbonyl carbon, reaction becomes slower. There is another reason, from electronic factor also you can give the answer. Now see here, this carbon is having partial positive charge. So as the number of alkyl group increases on this carbon due to positive inductive effect, positive charge on carbonyl carbon decreases, and this reaction will become slower. So from electronic reason, by inductive effect, you can give the answer. Now see, in the butanone, plus I effect of CH3 and C2H5 both are present, and plus I effect of CH3 CH2 is more than CH3. So rate of reaction will be slower for this than this, because here two methyl groups are there. So here for butanone, rate is very slow. It will be slightly higher for acetone. And you know, aldehydes are having much more higher rate than ketone for nucleophilic addition reaction. Ethyl is having higher plus I effect than methyl. So it will decrease here positive charge density, attack will become slower. So between these two, this is having lower rate, but it is higher than ketone. After that, this will come, and in formaldehyde means methanol, there is no steric reason, and also here no alkyl groups are present, so here rate will be highest. Next problem is for nucleophilic addition reaction, write the increasing order for the reaction rate. This is acetophenone. Acetophenone means its structure is this one, C6H5 COCH3. Para-tolualdehyde, this is CHO and here CH3. Para-nitrobenzaldehyde, para-nitro, and this is benzaldehyde. For nucleophilic addition reaction, what we have to see? The rate of reaction is proportional to positive charge density on carbonyl carbon. Now see, nitro is electron withdrawing by -m and -I effect. CH3 is electron donating by +I and positive hyperconjugative effect. Here no such group is present. And here this is ketone. Ketone means here rate will be slowest. Now this, due to this electron withdrawing nitro group, it will abstract electron density and this carbonyl carbon will become much more positively charged. So for this one rate is highest. Then benzaldehyde. Then here para-tolualdehyde, because due to +I and positive hyperconjugative effect, positive charge density is decreasing here, so rate will be decreased. So since it is ketone, so here for acetophenone rate is slowest. So now order is acetophenone is slowest, then para-tolualdehyde, then benzaldehyde. It is having much higher rate than this one, and this para-nitro benzaldehyde is having highest rate. Next problem, arrange these compounds in increasing order of reactivity for the nucleophilic attack. Now see, this is acid chloride, RCOCl, general formula. Aldehyde, RCHO. Ketone, RCO, R or R prime. Ester, RC double bonded O, O R prime or OR. Now see, Cl is having stronger -I effect. So it increases positive charge density on this carbon. And you know, between aldehyde and ketone, aldehyde is more reactive for nucleophilic attack than ketone due to steric and electronic reason. Aldehyde is more reactive. Now OR prime is having, it is having lone pair of electron. So it is involving in resonance like this way. So it is having +m effect and -I effect, since oxygen is electronegative, but +m effect is stronger here. Due to +m effect, positive charge density on this carbon will be decreased. So acid chloride, this carbon is having much more positive charge density, therefore this is much more reactive than aldehyde. And due to +m effect, positive charge density is much more lower than this, because here +I effect is there, and you know resonance effect is much more stronger than inductive effect. So here this effect will be much more stronger than here than this effect. So here rate is lowest. So this is the increasing order. Now next question, the increasing order of rate of HCN addition to compound A to D is. HCN addition to carbonyl compound is nucleophilic addition reaction. So here also at the first step what will happen? Cyanide will attack here. So if your positive charge density on this carbon is more, the rate of reaction will be more. So this is aldehyde, others are ketones. So it is having highest rate. After that, in this ketone, two methyl groups are there. Plus I effect of two methyl groups will decrease the positive charge density. But here one methyl group is there, one benzene ring is there, and pi bond of benzene ring is involved in resonance and decreasing this positive charge density. And here this carbonyl group is involved in resonance with this benzene ring and also with this benzene ring. So here positive charge density is much more decreasing than this. And you know resonance effect is always much more stronger than inductive effect. So positive charge density on this carbon will be decreased here. So this is least reactive. D is least reactive, then C, then B, and this aldehyde, formaldehyde is most reactive. This is the order D, C, B, A. In this video till this, if you like, please subscribe. Thank you for watching.